Alrighty, part 2 of your review key here. So the graph of f is shown above, so we want to make sure we're paying attention to what we're looking at here. From -4 to 4, alright, consists of 3 linear pieces. We've got selected values of g right here in the table, and piecewise h. Let f inverse and g inverse represent the inverse of f and g respectively. Use the information to evaluate the following if possible. All right, remember this whole if possible is important there. So we're going to work from the inside out. F of g of 8. So I'm going to find g of 8. So g of 8, my input is 8, my output is 4. So that means I really just want f of 4. So I go to f, my input is 4, my output is 5. The answer is 5. All right, so h of f of -4. So the first thing I look for is f of -4. So -4 gives me -5. So then I want h of -5. Here's h. Okay, -5 is less than -4, so I've got to substitute it into this first one. So this is going to be equal to 2 times -5 minus 8. So that's -10 minus 8, which is -18. Oh no. Oh, -2. Chutes and ladders. That's a -2. I didn't write that down. Okay. Let's rewind a little bit here. Most of the time I actually stop and literally rewind. I'm just not going to. All right, so that's a -2x. Let me make sure I write it down correctly. -2 times -5 minus 8. So that's a +10 minus 8, which gives me 2. There we go. That's correct. All right. So then I want f of h of -2. So that means I first need to find h of -2, and so I got to figure out which one this goes into. I haven't been writing it out like this, but I'm going to write h of -2. So -2 is greater than -4, so this is going to be -2 squared plus 9, which gives me -4 plus 9, which gives me 5. So then that means I want f of 5. All right, so f of 5, when I go to 5, f of 5 is not defined. So this is undefined. So this is not possible. All right. F inverse of h of -4. Have we found h of -4 yet? No. So here's h of -4 is just -3. So that means I just want f inverse of -3. So since this is the inverse, when I go to f, I'm not looking at x. Okay, I'm doing the opposite because it's the inverse. I go to the output of -3, and the input there, would be 0. And then I know there were some questions on the review on the key that was in class because it was written like that, which is the answer is 0. But then we can it was rewritten just to kind of make sure you understand that f of 0 equals 3. Okay, so the answer to this is 0. All right, g inverse of f of 3. So g inverse f of 3, 3 is 2. So g inverse of 2, so that's the inverse, which means I look at the output of 2, my input is 0. This one is 0 also. Okay. Then I want g inverse of f inverse of 5. So I'm going to do f inverse of 5 first. Since that's the inverse, I go to the y value of 5, gives me an x value of 4. So that means I really want the g inverse of 4. So g inverse of 4, I look at the output, gives me an input of 8. Alrighty. So now we are going to find, this is F, this is G, and I want G of F of X, G of F of X. I like to rewrite that. And so I'm going to take F, substitute it in for G. So that gives me, taking this, substituting it everywhere there I see an X. So that's negative 2, open my parentheses, 2x squared minus 6x plus 15. Okay, so that was just this x part. I can't forget about the minus 4. Then I distribute my negative 2. It's going to give me negative 4x squared plus 12x minus 30 minus 4. So G of F of X equals negative 4x squared plus 12x minus 34. Alrighty, then I'm going to do it the other way. F of G of X. So this is going to get substituted in everywhere I see an X there. So this is going to be 2, and then negative 2x minus 4 squared minus 6 times negative 2x minus 4, excuse me, plus 15. So I have to square this and square this legally. I don't get to just square both of these. This is like doing negative 2x minus 4 times negative 2x minus 4. Then you're going to FOIL it or do whatever it is you're going to do, whatever you want to call it. But I multiply the first two together. That gives me a positive 4x squared. The outside two together is going to give me a positive 8x. Inside two together, positive 8x. Last two together, positive 16. So that's just squaring this. So I'll put this back in here. 2 times 4x squared, and then those two 8x's become 16x, and then plus 16. Then I'm going to go ahead and distribute this negative 6, so that's plus 12x plus 24 plus 15. Now I'm going to distribute that 2 and get 8x squared plus 32x plus 32 plus 12x. Go ahead and add those two together, get a plus 39. Then I can finish it all up by saying f of g of x equals 8x squared. Okay, took care of that one. I got a 32x and a 12x. Be plus 44x plus, add these two together, 71. And that's my answer. Basic algebra. Can't stress that enough. You have to be able to do those things. Alrighty, so the graph of f is shown at the right, where -3 to 6 consists of 5 linear pieces. Let G represent, so G represent the inverse of f. So sometimes we call it f inverse, sometimes we call it G. We're going to answer the following if possible. So since I have a graph and I'm going to need to look at the inverse a little bit, I'm going to draw in my line. There we go. Okay. All right, so I want the maximum value of G, which is the inverse. Now, I can plot the whole thing. That's totally fine. But this point right here is the maximum value of f, or the maximum of f. This ordered pair is at 6, 7. Okay? If I reflect that, it doesn't reflect all the way down here. It just goes to right here. And this point's going to go over here. So that means this is still the maximum, but when I do the inverse, this becomes 7, 6. Remember, this is the x value is the location, the y value is the value. So the maximum value of G is 6. Then this point here is at -3, -6. If I reflect it, I'm going to get -6, -3 right there. So the minimum value, that's still going to be the minimum value because this is going to come here, this comes here, nothing else is going to be smaller than that. So the minimum value is -3. Okay. Then domain of G, range of G, that's just the opposite of what we have for F. So if I want to talk about F, the domain, I'm going from -3 to 6, and the range, I'm going from -6 to 7. So when I talk about the inverse over here, the domain is this range, so -6, 7, and the range comes from the domain, -3, 6. Okay? Alrighty. So here, this is the calculator portion. Now I helped a couple people with this today. They had it worked out by hand, and I helped them with that. I'll be honest with you, I didn't read that it said calculator portion, so we could do this by hand. Some people did and did it accurately. However, this is a calculator portion, so we don't have to. It does say that it can be modeled using a geometric sequence, so that right there should scream exponential. Okay, it's an exponential function. Where 2006 is year 1. The account had $6,730 in 2007, $8,200 in 2010, determined the value to the nearest cent. See here, it's telling you how to round for money for the year 2019. Okay, I highly, highly, highly encourage you when you were talking about time and years to count on your fingers. And since you can't see my fingers, this is what we're going to do. 2006 is year 1. 2007 would be year 2. So this is 26730. Okay, that's my ordered pair. Okay, 2010. So remember, 2006 is year 1. 2007, 8, 9, 10. We made 5 little dots. That means this is year 5. 8,200. And while we're at it, let's figure out year 2019. Okay, so year 1 was 2006, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19. Now again, you can do that on your fingers, but you can't see mine. So that's 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14. So this is when x equals 14. Okay, and that's all it's asking you for. It is not asking you for the equation or anything. We can write it down, but we don't necessarily need it, but we do need to do it. Okay, so I can use regression. I have 2 points. Come over here, my table, my ordered pairs were 2, 6730, and 5, 8,200. Okay, and I can zoom in on that. Regression, exponential. Remember, if it shows a log mode button to do that, if you just have 2 points, it won't show that, but that's what we're looking for. Now, and we just said over here, this is 14, and that's really my x value. Okay, so then I'm going to come back over here, and I'm going to type in x equals 14. X equals, oh, what the heck? I don't know what's happening with my emoji there. I don't want that. I want x equals 14. And I'm going to hit enter. Now I can't see it, okay, and that's because it has it zoomed in here. But if I just zoom out a little bit, oh, look, there it is right there. There is my ordered pair, and it says to the nearest tenth of a cent. Or it says to the nearest cent, really, but So you get f of 14 equals 14,832.3586. Like that's what the calculator gave you. So your answer then can just be $14,832.35. Do not round. There's some of you that haven't been truncating, you've been rounding, which it's fine. If you absolutely want to round, that's fine. But one of those people that's been stubborn and been doing that rounded wrong on a retest and then didn't get credit. So don't round, just stop. Just write it down and you're done. Okay? All right. Second one here. A new car is purchased for $20,700. The value of the car depreciates at 13.75% per year. What will the value of the car be to the nearest cent after 12 years? All right, so here we have to write the equation, all right? And remember, it's y equals a times b to the x. So your a is your initial value. That is your 20,000. Your b is your ratio. This is depreciating. So I would subtract that from 100%, basically. So this is 1 minus 0.1375 to the x power. And you can make this into one number of b if you want to, but I would just say just put that in the calculator just like it is. So we're going to go over here. I'm going to mark this out. I do not need to do a regression. Well, not only do I not need to, I don't have enough information to do that. So I'm just going to say y equals 20,700 times 1 minus 0.1375. Close my parentheses. Oops. Close my parentheses. And then to the x power. So there's my function, okay? And then it says, and it's not, I have to write this, like I have to have it to use it. They didn't actually ask me for it, but I need it there. And if you write it down and you don't write it down correctly, then maybe you could still get credit if we want to do this. But when I'm going to evaluate this at x equals 12, because that's the time, right? Now I pay attention to, I want it after 12 years, and this is per year, because it could be months or weeks or something, and I got to pay attention to that. But it's 12, so I'm going to go back over here, type in x equals 12, and then I need to move this around to get right there. Looks like 3508, okay? So f of 12, basically, or whatever you want to call it, is 3508.1616. That's what the calculator gave me. So my actual answer is 3508.16. I highly suggest you write down what the calculator gives you and then also, your actual answer. Okie dokie. Let's look at 10. It says the table above gives the number of bacteria present in a certain culture over a 6-hour period. Okay, so this is hours and bacteria, where x is the time in hours, y is the number of bacteria. Using exponential regression, it's like literally telling me what to do. To model these data, what is the number of bacteria present after 14 hours? Okay, so I have to write my equation, or I have to get my equation first. So I'm going to come back over here. I'm going to X those out. I need a table. So my X values are 0, 1, 3, 4, 5, 6, and then 1235, 1502. And y'all know for a fact that I definitely have to double check mine after I type them in. You need to type that. You need to do that as well, because when I'm grading these tests and your retests and stuff, I have a feeling when you're close that you probably just typed a number in wrong or something, but I can't necessarily figure out what that is and what you did. Okay, so let me double check my numbers here before I go off the rails. Okay, I think I'm good. So I'm going to zoom in. I'm going to do my regression. And it told me, I don't care how much I might like linear, it told me to do exponential. Then when I look here, look, I have a log mode. I have to click it. Okay, so I click log mode. Then this gives me y equals 1300.15679 times 1.13967 to the x power. Okay. It did not ask me for that, but it could ask you for that. And had I known the direction that Desmos was going with this, because now they're showing us 5 decimal places, then from day one, because remember, you have to be correct till at least 3, instead of having you write 4, I would have been making you write 5. So it's fine just to write them all. But I need, what it's asking me for is the number of bacteria present after 14 hours, where our hours are our x's. So we're going to evaluate this as at x equals 14. Even though we just wrote this down, I am not putting 14 right here and calculating this by hand or typing it in. I am using the graph and what the calculator did for me. So here I just type in x equals 14. And then I go find that. Whoops. Oh, got a little crazy there. All right, hang on a second. Let me. There we go. I get 8108.65. Okay, so y equals 8108.01675 bacteria. The other thing when doing these, make sure you're understanding what is the input and what is the output. Okay? Then it says use the model, what Desmos has in it, to find the residual at x equals 5. All right, residual at x equals 5. And y'all, it says find. Even on the retest for this, you can't just find it and then like know it in your head. You have to put what it is. So your residual is actual minus predicted. So the actual at 5 is 2518 minus the predicted at 5. So over here, I'm just going to change this 14 to 5 because I don't need it all in there. And I definitely want to zoom in. Otherwise, I don't know exactly what I'm getting there. Sorry, my paper keeps touching it. Oh my gosh. So I want to zoom in right there. See, that's the actual. There's my predicted. Maybe. I think it let me a minute ago. There we go. 2499 point. Okay, so I've got minus 2499.74287. And you're going to use all of those numbers to actually subtract. Okay, so we're going to add a few more so I can do this here. So I have 2518 minus 2499.74287. Okay, and that gives me 18.25. This equals 18.25713. Oops, that's not a 3. But had I done that, it would have been okay because I only have to be correct to 3. But that is my residual. Actual minus predicted. And then it said, is the value predicted an underestimate or an overestimate? So some of y'all have been putting things like, it's an overestimate because it's under the point or because it's greater. You really have to talk about it in terms of the residual. The residual is positive, therefore, but you can, I mean, if you're not sure, look, this is clearly an underestimate, right? And the reason is because the residual is positive, but it doesn't even ask me for a reason here. It's just underestimate. There we go. Then it asks me for, says use the model to find the error at x equals 2. So error is the other way around. It is predicted minus actual. It's RAP and EPA, right? And so my predicted at 2, got to go find that, so I'm going to X those out. At x equals 2, find that right here. Bam, right there. 1688, okay? So this is 1688.71193 minus the actual, which is 1757. And when I do that, and I come over here and I actually subtract them, the whole numbers there, 1688.71193 minus 1757 gives me negative 68.28807. And this asks if this is an underestimate or an overestimate. So remember, you can just think about residuals. If the residual is negative, it's an overestimate. So this is the error, it's opposite. So this is an underestimate also. Okay, and that's the end of part 2.